ReachMD XM157 now presents this month's special series, Exploring Heart Health.
You're listening to ReachMD, the channel for medical professionals. Hi, this is Dr. Ann Goldberg, president of the National Lipid Association, and I'd like to welcome you to Lipid Luminations, hosted by Dr. Larry Kaskel, presented by the National Lipid Association.
Joining me today is Dr. William Virgil Brown, editor-in-chief of the Journal of Clinical Lipidology, and Charles Howard Candler, professor of medicine at Emory University School of Medicine. Dr. Brown is the chief of medicine at the Atlanta VA Medical Center. Dr. Brown, welcome to the show.
Thanks for having me.
Today we're going to talk about a doctor who really made a major impact in the field of lipidology, Dr. John Gofman. Who was he?
Dr. Gofman is one of my heroes. He is a very interesting gentleman from many aspects, an excellent scientist who was a professor at the University of California in Berkeley. Dr. Gofman held both a PhD in nuclear physics and an MD and made major discoveries in several areas of science. The reason that I am in particular enamored with his career is that he was the first to really define the particles in our blood that carry cholesterol and triglyceride in a very precise way, and showed initially that these particles had specific linkage to vascular disease.
How did he even think about doing that? What kind of career did he start with?
Well, very interesting. He actually was a graduate student at Berkeley at the time of the Manhattan Project, and during his graduate student days, he was asked to try to isolate the isotope plutonium, which became a component of one of the bombs actually dropped on Japan in fall of 1945. His job was to try to isolate enough plutonium so that they could actually study it chemically. Tiny bits of this material, this element, had been isolated previously. And within a year or so after being assigned this task, he had several milligrams of the material, which allowed the initial chemical isolation and description of plutonium so that it could be worked on as an element in the weapon. He then went into other aspects of nuclear physics and described some of the isotopes of uranium, which were also fissionable. Fissionable means that it will blow up, that it will act as a component of the weapon. And he worked with other scientists out there and really described a formula that would allow you to predict which nucleus could be fractured, broken, and give off energy. So he did fundamental work in nuclear physics. Now, he was also a naval officer, went into the Navy, and as he came out, he went to medical school at the University of California in San Francisco and was voted the top student in his class as a medical student. When he finished that, he decided that World War II was then over, of course, and he had all this experience with isolating isotopes, which involved an instrument called the analytical ultracentrifuge. This device was used to isolate isotopes. It allows you to put material into a machine that spins it very fast and, in effect, creates force that's thousands of times that of gravity. And because the weight of molecules are different, you can separate molecules. Well, when he finished and now the World War II was over and the need to rush into the nuclear business was over, he devoted himself to biological questions. And looking around, he decided that separating components of blood in the ultracentrifuge would be very interesting because many of the components in blood had not been defined at that point. And in the process, they found that some of the particles, instead of going down as they should in an ultracentrifuge, sinking rapidly, they were floating. They were going to the top of the centrifuge. And it took them a little while to figure out exactly what was going on, but then they realized that what they were looking at were particles that were filled with fat. And of course, as you know, cream rises in milk, and fat particles float. And indeed, in human plasma, these particles stay suspended because they're very tiny. But when you put them under a big force field, as an ultracentrifuge will do, they then begin to float very rapidly. And by using the flotation rates, the rate at which these little particles floated, he was able to define very low-density lipoprotein, low-density lipoprotein, and high-density lipoprotein. And now those have all become household names.
He really fell into it. He was just looking at blood and discovered all this by accident.
Yeah, well, I would say by a very educated serendipity, if you will.
Serendipity is better than accident.
Yeah, I mean, he had to recognize what he was seeing, and it was a puzzle for a while. And one of his graduate students, Frank Lindgren, who worked at Donner Laboratories at Berkeley for many, many years on lipoprotein metabolism, was actually the one who sort of had the spark of the idea as to what they were seeing in the patterns that they were looking at. Then he and Dr. Gofman and others in that laboratory just took off with this and began to describe the characteristics of animal plasma as well as human plasma. They described the rabbit and how it changes when you feed it high cholesterol with regard to these particles, and how the particles related to atherosclerosis in the animal model. And then they set up several studies in individuals with various diseases, including diabetes. They went out to the Livermore Laboratories, which is a big installation out in the valley there to the east of San Francisco, where this was a weapons plant, very important in World War II and later, and studied the population of people in Livermore, California, and related the particles that they could measure in the centrifuge to the prevalence and the incidence of vascular disease. And they showed for the first time that HDL, the high-density lipoprotein, did not cause or did not correlate with vascular disease in a positive way, but it was the low-density and the very low-density lipoproteins that predicted vascular disease. And this was really the first time that had been done.
If you've just joined us, you're listening to Lipid Luminations on ReachMD XM 157. I'm your host, Dr. Larry Kaskel, and joining me today is Dr. William Virgil Brown, editor-in-chief of the Journal of Clinical Lipidology and chief of medicine at the Atlanta VA Medical Center. And we're talking about the life and times of John Gofman. Dr. Brown, you mentioned that he discovered LDL and HDL and triglycerides, but you mentioned that HDL didn't really show a correlation back then.
That's correct. And in fact, when you look at his data, none of it actually showed the same thing that we have been measuring with the cholesterol component of HDL. And so many of us over the years have puzzled over the measurement of the particle in the ultracentrifuge versus isolating and measuring the cholesterol component in the HDL. You know, HDL is many things. It's mainly protein, actually. Cholesterol only makes up about 25% of the weight, the mass of HDL particles. The rest is other types of lipids like phospholipids. And so there may be still something unexplained there. Certainly from his data and current data, there's a disconnect. And we need to find out what that is. We now know that HDL is very complicated, that there are 10 to 15 components of HDL that are very reproducible in human plasma, and that these things are constantly exchanging and being converted from one into the other by action of enzymes in the blood and transfer proteins that are removing lipids and adding lipids to HDL particles. So there's a lot of complexity here in HDL. We've been trying to change HDL for years because we thought if we raised the cholesterol component, we would see protection. But that's been hard to prove. As you know, recently the story with torcetrapib, where HDL was raised markedly, and yet we had increase in heart disease.
Right. Well, I know now that we're learning a lot about that HDL actually has two faces. There's a anti-inflammatory face of it, and it can actually take on a pro-inflammatory behavior.
That's exactly right. And because the lipid components and the state of oxidation of those lipids change constantly, and they're different in different people. So HDL is something that is still worthy of a great deal of study, and the fact that Dr. Gofman would not accept that it was a protective factor in his studies is an important red flag that we should have been monitoring and recognizing for a long time.
Well, besides plutonium and finding lipids, what else did Dr. Gofman do to kind of affect the everyday man?
Well, it's an interesting story because at the middle of the 1960s, it was pretty well accepted that cholesterol in the blood was related to heart disease and was an important predictive factor, that is the total cholesterol, because LDL dominates the total cholesterol in the blood. So the National Institutes of Health decided to organize a study in which they were going to investigate this issue further, and we're going to change diet in thousands of people to show that dietary reduction of cholesterol would in fact prevent heart disease. And Dr. Gofman was one of the people who was on the panel to design this study. He, feeling very strongly, based on his data already, that lipoproteins were really the important measure, not just total blood cholesterol. He insisted, that they incorporate this into this new study, and the epidemiologists who were on the panel rejected his work. Basically, said this is, it's an overblown issue. And after this experience, he said, this field is not going where I want it to go, and he quit. He just basically dropped out of lipoprotein work. It was an amazing period of about 10 years, really, 1948 to 1958, that his work was just extremely important and laid the groundwork for lipoprotein work in the future and still on today. Well, at that point, when he left lipoprotein studies, he returned to nuclear physics, and here, working at the Livermore Laboratories, he devoted his time and effort to studies related to the Hiroshima and Nagasaki injured, irradiated people, and also to radiation studies in animals. And his question was, what are the consequences long-term of being exposed to nuclear radiation? And he became convinced that even small doses in large populations had an impact on risk of cancer. And over the remainder of his life, as a matter of fact, he wrote articles and books, presented statistics that showed that there was a relationship with the incidence of cancer, even at what we thought were very safe and low levels of radiation. When you apply the percentage change across the entirety of the population, it reached differences of thousands of people, over years. And at the time, in the late 60s, we had these wonderful ambitions to use the explosive power of nuclear weapons to do good things. We were going to widen harbors. We were going to create a new canal across the Panama Isthmus with nuclear weapons. We were going to have over 1,000 new nuclear plants across the country. And Gofman became a sort of lone voice in the wilderness saying, this is crazy. You can't put all of this radioactive nuclear material into the atmosphere and have it out in communities without proper study, because the radiation exposure offers a tremendous risk to the population as a whole. And he fought this very hard and really was accused by even congressmen of being a nut. But his impact has been a much more cautious approach to the exposure to nuclear and radiation in general.
Well, Dr. Virgil Brown, thank you again for coming on the show today.
My pleasure.
Thank you for listening to Lipid Luminations, presented by the National Lipid Association. For more information, please visit www.lipid.org. ReachMD, the channel for medical professionals.
Thank you for listening to this month's special series, Exploring Heart Health, on ReachMD XM157, the channel for medical professionals.